I want you to imagine just for a moment that you are walking into the grand atrium of a luxury hotel.
Oh, I love those massive hotel lobbies.
Right. Picture the scale of it.
Hmm.
You've got these soaring, multi-story ceilings right above you, massive glass walls letting in the fading evening light. And the space is just, well, it's utterly cavernous.
Yeah, they're designed to make you feel kind of small, honestly.
Exactly. And there's music playing like a lively, upbeat big band tempo. You are surrounded by hundreds of people.
Sounds like a great party.
It is.
You know?
Everyone is dressed up, having a fantastic time. They're laughing, holding drinks, just swaying to the rhythm. And as you walk through this open space, you're completely, implicitly trusting the literal roof over your head.
Which is something we all do.
Yeah.
Every single day.
Exactly. You're trusting these sleek, modern, concrete and steel walkways that are just crossing the empty air above you. You don't even think about it. You just exist in the space, assuming the world around you is solid.
We navigate our whole modern environment with that underlying assumption. I mean, if a massive structure is standing there, we just assume it belongs there.
Yeah, we assume it's safe.
Right. We assume that a whole team of highly educated professionals has, done the math, run the simulations, and guaranteed our safety.
So let's ground that image in a very specific time and place. Let's transport you to July 17th, 1981.
Okay.
We are at the Kansas City Hyatt Regency. And that vibrant scene I just described, that is exactly what was happening. It was a Friday evening tea dance.
A really big event for the city, too.
Huge. The atmosphere was just electric. People were dancing on the ground floor, and dozens more were standing on these suspended walkways that hovered straight over the dance floor, just, watching the band.
Just enjoying the view.
Yeah. But then, in a matter of seconds, that invisible trust we all take for granted was completely shattered. Two of those massive suspended walkways simply gave way.
It's horrifying to even think about.
They collapsed, pancaking down onto the crowded atrium floor below.
And the sheer scale of the devastation in that single moment is just difficult to fully comprehend. In an instant, 114 people lost their lives.
Oh my God.
Yeah. And over 200 more were severely injured. To this day, it actually remains one of the absolute deadliest structural failures in the history of the United States.
Okay, let's unpack this, because our mission for today's deep dive is not just to recount the horrific tragedy of that evening.
Right, there's a lot more to the story.
Exactly. We've got a massive stack of sources on the table today. We're looking at historical news reports from the immediate aftermath, incredibly detailed architectural blueprints.
The federal investigation transcripts, too. Those are key.
Yes, and foundational engineering case studies. We're going to use all of these to look at the terrifyingly simple engineering flaw that caused those walkways to fall.
It really was terrifyingly simple.
And we're going to explore how one tiny, seemingly administrative tweak forever changed the way we build the modern world.
Because that stack of blueprints you mentioned, that is where the real mystery lies. But before we get into the physical mechanisms of why the steel gave way, we have to recognize the psychological shock of this event.
Right, because this wasn't some ancient crumbling ruin.
Exactly. We are not talking about an ancient structure here. We aren't talking about a building that had been weathering hurricanes or, massive earthquakes for 50 years.
This is a brand new flagship hotel. I mean, it had only been open for about a year.
Which is exactly why the emotional weight and the public panic following the collapse were so profound. We often treat engineering as this abstract, highly insulated discipline.
Like it's just complex calculus on chalkboard.
Right. It's computer models, it's reams of safety regulations.
Yeah.
But the human cost of the Hyatt Regency collapse is a brutal reminder that engineering is not abstract at all.
It's intimately tied to human lives.
Yes. Those lives depend entirely on those chalkboard numbers being flawlessly correct. The shock of a state-of-the-art structure failing so catastrophically during a celebration, it completely broke the public's illusion of safety.
I keep getting stuck on that exact point, honestly. And I think anyone listening to this has the same fundamental question that I do.
How does it happen?
Yeah. How does a modern high-profile building, presumably constructed with the absolute best, cutting-edge contemporary practices of 1981 just suddenly fall apart during a dance?
It defies common sense.
We expect ancient ruins to crumble. We don't expect a luxury hotel walkway to just drop out of the sky without any warning. Were they, ignoring massive cracks in the walls? Was there a foundational earthquake?
Well, to answer how a building of that caliber could fail so suddenly, We have to look past the grand architectural vision. We have to peer very closely at the microscopic details of the steel hanging from the ceiling.
The actual nuts and bolts of it?
Literally, yes. The answer wasn't a localized earthquake or a bomb or some radical new architectural theory that proved unstable.
So what was it?
The answer was a seemingly minor, almost administrative level adjustment made during the construction phase.
An administrative adjustment. Are you serious?
Yeah, it was an adjustment that completely changed the physical reality of the structure, yet somehow slipped past every single person who was supposed to be paying attention.
Here's where it gets really interesting. Because the flaw wasn't in the sweeping aesthetic design of the atrium, right? It was hidden in the joints.
Exactly. And what's fascinating here is that the original design of these walkways, as drafted by the structural engineers, was entirely structurally sound.
Wait, really? The original blueprints were safe.
Perfectly safe. Let's visualize that original plan from the blueprints we have. So the atrium featured these long walkways suspended midair.
Okay, I'm picturing it.
The fourth floor walkway was positioned directly above the second floor walkway. The original engineering plan called for them to be supported by a single, continuous steel rod hanging all the way down from the ceiling.
So picture one really long, thick metal pole attached securely to the roof structure, hanging straight down towards the ground.
Precisely. That continuous rod would pass right through the steel box beams of the fourth floor walkway, and then keep going down through the air to pass through the steel beams of the second floor walkway.
Okay, so it threads through both floors.
Right. And to hold the walkways in place on that rod, the design called for a heavy-duty nut and a washer to be threaded onto the rod directly beneath the fourth floor, and another nut and washer threaded at the very bottom beneath the second floor.
I can visualize that. So the rod itself is doing all the heavy lifting. It's carrying the weight of both floors up to the ceiling in tension.
Exactly. The tension goes straight up that continuous rod. But during the actual construction phase, the steel manufacturing contractor ran into a severe logistical headache.
Logistical. Like it was just too hard to build.
Yeah, pretty much. Procuring, threading, and installing a single massive continuous steel rod that was over 40 feet long, and somehow keeping it perfectly straight and undamaged while maneuvering it into a busy atrium was highly impractical.
I mean, that does sound like a nightmare to install.
It was. So they proposed a change to make the assembly easier. Instead of one continuous rod spanning the whole distance, they decided to use two shorter, separate rods.
Honestly, on paper, to someone who isn't a structural engineer, that sounds like a perfectly reasonable workaround. You just cut the rod in half to make it easier to carry through the front doors. What is the big deal?
Well, the fatal error lies in how they connected those two separate rods.
Okay.
They hung the first rod from the ceiling down to the fourth floor, securing it with a nut and washer underneath the fourth floor beam.
That makes sense so far.
Then they attached a second, completely separate rod to the bottom of that exact same fourth floor beam and hung the second floor walkway from that lower rod.
Oh, wow. Okay, I want to make sure I'm wrapping my head around the physics of this.
Yeah.
Imagine hanging like two hammocks from a really high ceiling.
Okay, I like this analogy.
If you have one sturdy, long rope hanging from a massive ceiling hook, and you tie the first hammock high up on the rope, and then tie the second hammock lower down on the exact same rope.
The original design.
Right. The rope itself is absorbing the weight of both hammocks and transferring it up to the ceiling hook. If the ceiling hook is strong enough, you're totally fine.
Exactly.
But they altered the setup. They hung the top hammock from the ceiling hook. Then, instead of attaching the bottom hammock to the main rope, they tied the ropes of the bottom hammock directly onto the physical fabric of the top hammock.
That hammock analogy captures the mechanical shift perfectly. And to take it a step further, imagine the canvas fabric of that top hammock was never stitched or reinforced to hold the weight of two people.
Right. It's only designed for one person.
Exactly. It's only designed for one. The moment someone climbs into the bottom hammock, that extra weight pulls down on the fabric of the top hammock. It's going to tear right at the seams where that second rope is tied.
And in the case of the Hyatt Walkways, that hammock fabric was a hollow steel box beam.
Yes.
So suddenly, all the combined weight of the people standing on the second floor walkway is pulling straight down on the fourth floor walkway's internal structure.
You got it.
The nut and washer holding up that top walkway aren't just holding the fourth floor anymore. They are carrying the entire burden of the second floor suspended beneath it.
It effectively doubled the load on a single connection point. In the original design, the nut under the fourth floor walkway only had to hold the weight of the fourth floor.
Because the rod itself carried the second floor's weight up.
Right. The continuous rod carried the tension of the lower floor directly past it, up to the roof. But in the altered design, that single nut had to hold its own floor, plus the entire weight hanging beneath it.
Double the load.
It was carrying double the load it was engineered to carry. And honestly, looking at the structural reports we have here, that connection was already somewhat marginal. It was barely adequate for its original single-floor load.
Which just terrifying.
Hmm.
So on the night of the tea dance, you've got dozens of people standing on both the second and fourth floor walkways. They're swaying to the music, adding dynamic movement to all that static weight.
Yeah, movement makes it even worse.
That single overstressed connection point on the fourth floor just couldn't take it. The steel literally tore. The nut slipped right through the deformed metal of the beam, and the whole system cascaded down.
It failed catastrophically.
But that physical failure leaves me with an even bigger question. How did investigators even find this microscopic change in a massive pile of twisted metal and concrete?
Well, investigators look for the origin point of failure by studying the deformation of the materials. When they dug through the wreckage, they found the steel rods were actually completely intact.
Wait, the rods didn't break.
No, the rods hadn't snapped. The nuts hadn't sheared off the threads either. Instead, they looked at the steel box beams of the fourth floor walkway and saw that the metal edges around the drill holes were curled upward and ripped outward.
Oh, like a torn piece of paper.
Exactly. The nuts had been pulled cleanly through the solid steel of the beam. That physical evidence told the investigators immediately that the connection failed, not the rods.
Wow.
And once they checked the fabricated connections against the original blueprints, the discrepancy was just glaring.
Which brings us to the domino effect of failure, because understanding the physical failure of those steel joints leads us directly into the systemic failure of the human beings involved in the project.
The human element is where it gets really tragic.
Right. We are talking about a massive commercial development.
Yeah.
There are architects, lead engineers, city planners, and site contractors. How does a major structural change just bypass all the safety checks?
That is the big question.
Was this a case of malicious, greedy corner cutting to save a quick buck? Or was it a deadly game of telephone where communication broke down and everyone just assumed someone else checked the math?
The investigation transcripts point overwhelmingly to the latter. It was a tragic, catastrophic game of telephone fueled by the fast-paced, high-pressure environment of commercial construction.
So no one was intentionally trying to build something dangerous.
No, not at all. The steel fabricator who realized the long rod was logistically impossible drafted a quick sketch of the two-rod alternative. They sent that sketch over to the engineering firm as a request for information, or an RFI.
I have to pause you there because that term feels really important. What exactly is the difference between a design change and a fabrication detail in this context?
That's a great question. A structural design change alters the fundamental physics or load-bearing nature of a building.
Okay, so a big deal.
Right. A fabrication detail is a minor adjustment to how a piece is manufactured or assembled, something that doesn't affect the overall structural integrity.
Like using a slightly different type of bolt, maybe?
Exactly. But in the early 1980s, the line between those two things and the communication protocols between contractors and engineers was dangerously blurry.
So the engineers looked at this sketch of the two rods and just saw a minor fabrication tweak to make assembly easier.
Exactly. They saw it, they glanced at it, and they stamped their approval on it without ever sitting down to run the new load calculations.
Oh my God.
It was an assumption cascade. The engineer assumed the steel fabricator had run the math before proposing the change.
Yeah, and the fabricator assumed that because the licensed structural engineer put their official stamp on the drawing, the engineer had validated the math.
Exactly.
So nobody actually sat down with a calculator and said, wait a minute, this setup doubles the load on this specific nut?
Nobody.
But even if the engineer and the contractor had this deadly miscommunication, don't there have to be city building inspectors? How does the city's oversight miss something that fundamental?
Well, city inspectors are generally there to ensure the construction matches the approved plans and complies with zoning and broad safety codes.
Okay.
They are not structural engineers rerunning the calculus of every joint in a high-rise. If an inspector sees an official, revised blueprint carrying the stamp of a licensed professional engineer, They take that stamp as a legal guarantee that the math is sound.
So the entire system of building oversight relies completely on the integrity of that single stamp.
Yes, it all comes down to that stamp.
That diffusion of responsibility is terrifying.
Yeah.
The idea that everyone is looking at the person next to them, assuming safety is being handled.
And when the investigators published these findings, it sent absolute shockwaves through the construction and engineering industries.
I can imagine.
The aftermath of this collapse completely forced a rewriting of how the entire field operates. Suddenly, everyone realized that an engineer's stamp couldn't just be a casual rubber stamp of approval to keep a project moving. It was a literal life or death guarantee.
You know, it seems like the biggest revelation from reading through all these sources is this core takeaway. Physical forces don't just disappear when you alter a design for convenience.
Yes, that is the concept of a load path, and that is a huge takeaway. Think of a load path as the literal route that weight and gravity take as they travel through a building, down the columns, and into the foundation.
Okay.
The moment the contractor changed that continuous rod into two staggered rods, they completely rerouted the load path. Gravity didn't vanish, it just found the next weakest point in the new path.
Which was that single nut bearing double the weight.
Exactly.
So the fallout from those broken communications and unreviewed changes didn't just end with a localized tragedy in Kansas City. It triggered a massive industry reckoning.
It really did. If we connect this to the bigger picture, the Hyatt Regency collapse serves as a stark dividing line in the history of modern engineering.
A before and after.
Exactly. Before 1981, the protocols for handling design changes during active construction were dangerously ambiguous. After the collapse, the American Society of Civil Engineers and regulatory bodies across the globe fundamentally rewrote their codes.
They made it so that every single change, no matter how small it seems on a dirty construction site, has to be officially vetted by the structural engineers of record.
Yes, no more casual sketches. Furthermore, it revolutionized the concept of peer review in construction. The industry realized that when you are too close to a project, when you are exhausted from deadlines and staring at hundreds of RFIs, you develop blind spots.
You just see two steel rods and think problem solved, instead of seeing a doubled load path.
Right. Today, independent checks are mandatory for complex structures. You need a fresh, completely separate team of engineers to verify the primary team's math.
And beyond just the procedural rules, there's a massive shift in engineering ethics, right? The engineers of record for the Hyatt Regency actually lost their professional licenses.
They did. They lost their licenses in multiple states because they failed in their ethical duty to ensure the safety of that design.
Even though they weren't the ones who originally drafted the two-rod change.
Even so, they put their stamp on it. That tragedy cemented the principle that public safety must always supersede project deadlines, budget cuts, or logistical conveniences.
Ethics are non-negotiable.
Absolutely. When you study civil or structural engineering today, the Hyatt Regency is a mandatory foundational case study in professional ethics.
Wow. It's just incredible to think about the invisible architecture of our daily lives. Going back to what we're discussing at the very beginning of this deep dive, non-engineers walk into massive skyscrapers every single day.
We do.
We drive our cars over suspension bridges spanning huge bodies of water. We sit under massive glass domes in shopping malls. We never once look up and try to calculate the sheer strength of a steel beam.
No, we just trust it.
We take that invisible trust completely for granted. But what reading through these investigation reports really highlights is that our modern peace of mind was paid for by the lessons learned from tragedies like the Hyatt.
It is a sobering realization, but an incredibly necessary one. Every bridge we cross, every high-rise we enter, carries the legacy of those 114 lives.
Huh.
The rigorous systems we have in place now, the systems that sometimes feel frustratingly bureaucratic to developers, they are written in the blood of past failures.
Those mandatory peer reviews, the endless sign-offs, the clear lines of communication.
They are the guardrails keeping that invisible trust intact. It reminds the industry daily that trust isn't just built on high-tensile steel. It is built on taking absolute responsibility for every single detail.
There was a phrase that popped up in the engineering literature we reviewed for this topic that really stuck with me. Safety isn't expensive, it's priceless.
That is perfectly said.
When you look at the cost of a few extra hours for an engineer to sit down and run the calculations on that rod change versus the staggering, irreversible cost of what actually happened, the math is undeniable.
The contrast is horrifying. A few hours of math could have saved 114 lives and prevented the collapse of a multi-million-dollar structure.
Right.
That is why the modern engineering ethos is so unyielding when it comes to protocol.
Okay, let's bring all of these threads together. Today, we've taken a deep dive into one of the most consequential structural failures in modern history. We looked at how a devastating loss of life at a 1981 tea dance was ultimately traced back to a seemingly tiny logistical tweak.
A single continuous steel rod was swapped for two shorter ones for the sake of convenience.
Right. Inadvertently doubling the physical load on a fragile connection point.
And through the wreckage, we saw how that single physical failure exposed a massive systemic breakdown in communication. It highlighted the danger of assuming someone else has checked the math.
But we also saw how that tragedy reshaped engineering codes globally, enforcing strict independent peer reviews, cementing ethical obligations, and proving that clarity on a job site is quite literally a matter of life and death.
It is a profound, heavy legacy.
It is. But before we wrap up, I want to leave you with a final thought to mull over. Because while this physical tragedy prompted a massive, industry-wide overhaul in structural engineering checks, it makes you wonder about the structures we are actively building today.
Oh, that's an interesting point.
Not the ones made of steel and concrete, but the ones made of code and data.
The parallels are definitely there. We've spent this entire discussion focusing on the physical world, but our modern society is increasingly run by vast, invisible digital infrastructure.
Exactly. Think about rapidly building, highly complex, and currently less regulated industries, like software engineering, global cybersecurity, or artificial intelligence. In those digital spaces, the load paths aren't carrying physical weight. They're carrying our sensitive data, our international financial systems, our power grids, and our hospital communications.
Which are just as critical to human life.
So it begs the question, what seemingly tiny, unreviewed changes are happening right now in the back end of the software that runs our lives?
Wow.
Could a tiny, unreviewed change in code, pushed out in a rush by a developer trying to meet a Friday afternoon deadline, cause a catastrophic societal collapse in the future?
I mean, we've seen digital outages cause chaos before.
Do we need a Hyatt Regency level wake-up call for the digital world before we finally implement those same rigorous independent checks?
It's a haunting parallel to consider.
Hmm.
Because just like the guests enjoying the music at that tea dance, we are all wandering through this massive digital atrium right now, completely trusting the invisible architecture hovering right over our heads.
Thank you for joining us for this deep dive. We'll catch you next time. Keep looking up and keep asking questions.